Hello friends, welcome to Susan and John MathTube. This is the second video in rectification. And in this video, we learn how to find the length or the arc length or the rectified length of a few standard equations. In the last video, we learned the formula for the length. So, if y equal to f of x makes a graph like this, and if you are interested in the length between x equal to a and x equal to b, then all you have to do is you write s is equal to, because that is called arc length, integral x equal to a to b root under 1 plus dy by dx the whole square times dx. All you have to do is you just evaluate this integral and you get the length. Okay, let's go for one very easy question. So the question is, find the length of the circle x square plus y square equal to a square. Find the length of the circle x square plus y square equal to a square. Okay, in your younger classes, you might have learned another word for length or arc length for the case of a circle. Yeah, it is called the circumference of a circle. So look at this. With the help of integration, today we are going to find the circumference of a circle. Anyway, you know the details of the circle which we have written here. X square plus y square equal to a square stands for a circle with center, origin and radius a. So I'm going to mark these 2 points. The x coordinate is 0 here, the x coordinate is a here. And I notice one more thing. If I can find this much length, all I have to do is multiply by 4 and I get the total length. So I write the formula: required length is equal to, or I can call it S, integral x equal to 0 to a. Since I am considering only the first quadrant, I have to multiply by 4. And the formula is root under 1 plus dy by dx the whole square dx. There are many methods to do. Today I am in a mood to do what we call differentiate trigonometric function. So I am going to transform this into a trigonometric problem. So do you remember the parametric form of a circle? Yeah. X is equal to a cos theta, y is equal to a sin theta. So look at this. If you want to apply the formula, you need dy by dx and you need dx and you need the limits of theta, because the parameter I used is theta. So we find dx by d theta, that is a times minus sin theta, and dy by d theta, that is a times cos theta. And we use the formula dy by dx equal to, I'm sure you know, dy by d theta by dx by d theta, which you might have learned in class 11. And that gives me second by first. So we end up with minus cos theta by sin theta. So I'll put a tick mark. We are going to use this. And from here, look at this, I have put a box. So we can find dx being minus a sin theta d theta. So I'll put one box here. We need this, we need this. Okay, now the last thing, the limits. So look at this, the x value, I know the x value. The x value is a cos theta. So cos theta is actually x by a. And that means theta is equal to cos inverse x by a. The lower limit is x equal to 0. So if I plug in x equal to 0, if I put x equal to 0, I get theta to be cos inverse 0 by a. But 0 by a is 0, cos inverse 0 is Yeah, 90 degree. And when I plug in the upper limit, that is x equal to a, I get theta equal to cos inverse a by a, that is 1, that is 0. So I found everything. I need to find this integral. So s is equal to 4 times, okay, I'll use some other color. Theta varies from pi by 2 to 0. I think you saw that. Instead of 0, I had to put pi by 2. Instead of a, I had to put 0. And root under 1 plus dy by dx is, there is a negative here, but I'm going to ignore it because I'm going to square it. So we get cos square theta by sin square theta. And dx is here minus a sin theta. I'm glad that there is a negative because I'm going to flip the limits. I love to write theta equal to 0 to pi by 2. I don't know why, but I love to say from smaller number to bigger number, but there is no compulsion like that in the limits. Anyway, when I flip the limits, there will be a negative. And negative of negative will be positive. Okay. And this a goes outside. And here what I do is I take LCM. So we end up with sin square theta plus cos square theta. The whole divided by sin square theta times, oops, minus is gone, a is gone, so only sin theta d theta. What is sin square theta plus cos square theta? 1. And don't forget we are inside a square root. So we end up with 1 by sin theta. And here we have sin theta d theta because that root of 1 is 1 and root sin square theta is sin theta. And that's it. Integral d theta is theta within the limits theta equal to 0 to pi by 2. We put the upper limit, so we get 4a pi by 2 minus 0. Simplify, cut, and we get 2a pi. Yeah, the answer is correct because I already know the fact a circle with radius r will have circumference 2 pi r. And in this example, the radius was a, that is why we got 2 pi a. Now, time to try another question. That is a parabola. I am interested in the length between the vertex and the focus above the x-axis for this parabola. Okay, so the first thing, draw a graph. So y square means symmetric about the x-axis. So look at this. Y square means symmetric about the x-axis. See, half the area is above, half the area is below, symmetric about the x-axis. Now the question is, find the length between vertex. You might have learned in high school, the vertex is 0, 0 and the focus is a comma 0. Anyway, I'm interested only in the x values. So I'm going to cut that and write x equal to 0 here, and at the focus x is equal to a. Look at this. I want to find this length because they told find the length between the vertex and the focus above the x-axis. Otherwise, I have to multiply by 2 times. So I am ready with it. So I am going to write the formula s is equal to integral. Should I multiply by 2? No. It is mentioned in the question, find the length above the x-axis. So x equal to 0 to a root under 1 plus dy by dx the whole square dx. Okay, so I am ready with the formula. So we have to find a few characters. Okay, the derivative. So I'll write that here. Y square equal to 4ax. So differentiating with respect to x, we get 2y dy by dx is equal to 4a times 1. So dy by dx is equal to 2 and 2 will get cancelled. So 2a by y. So dy by dx, the whole squared will be 4a square by y square. But y square is actually 4ax. So I get 4a square by 4ax. So cut, 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 cut. I get a by x. I hope you can read that. So root under 1 plus dy by dx, the whole square, is equal to root under 1 plus a by x, and that will be root under, take LCM, a plus x by x. Okay, now ready to substitute. So s equal to integral x equal to 0 to a, root under a plus x by x dx. I think you have seen this problem in improper integrals. Actually, in lesson number 19, I gave the same question so that you will be good with the applications of integration. This is an improper integral because when you plug in x equal to 0, you're going to get infinity. But this is a type where we can escape the improperness by substitution. And the substitute is very easy. X is equal to a tan square theta. Look at this. This might be a little bit lengthy method, but today I am in a mood to do trigonometry. So I just converted it into trigonometric function. Some people might use the substitution 1 plus a by x equal to t square, and they will also get the answer. So anyway, today let's try with trigonometric method. It might be a little bit long, but let's give it a try. So there are two things which you should do after you substitute. If you ask me why I made this substitution, it is because of a plus x. Because if I plug in a tan square theta here, a will come common, 1 plus tan square theta, that is sec square theta, and I will be outside the square root. So the first thing, dx, the differential, a into, this is actually tan theta the whole square. So 2 tan theta into sec square theta d theta. So we need this. And the second thing to do, you have to find the limits. We are converting x into theta. All we know is the limit of x. We have to convert it into theta. So look at this, my friends. Tan square theta is x by a. So that means tan theta will be root under x by a. Or theta will be tan inverse root under x by a. Now look at this. I told you we know the limits of x. So if x is equal to 0, that's the lower limit, we get theta is equal to tan inverse root under 0 by a, that is 0 by a is 0, so we get 0. And the upper limit is x equal to a, so we get tan inverse root under a by a, that is 45 degree. So let's substitute. So we get s equal to integral theta is equal to 0 to pi by 4 root under a plus a tan square theta, the whole divided by a tan square theta times what is dx is here, a into 2 into tan theta into sec square theta d theta. Okay, now I'm going to write this 2a outside. Theta is equal to 0 to pi by 4. Here a comes common. And I know 1 plus tan square theta is sec square theta. And we end up with root a sec theta. I hope you are able to digest that. By root a tan theta. It's not that hard. You can understand that part. And multiplied by tan theta, multiplied by sec square theta, d theta. So this tan theta, root a gets cancelled. We get another headache. I told you this trigonometric method is not that efficient, but I already told you today I am in a mood to do trigonometry, so I just converted it into the trigonometric form. And it is mathematics. You can use any method you like. Okay, now let's get ready for integration. So I'm going to call this I, integral sec cube theta, as I. And then I'm going to apply integration by parts. We get first function. I hope you remember the rule. I'll write the rule here. Integral uv equal to integral u integral v minus integral differential of u integral v. Basically this and this will be the same. Okay, one more fact. The derivative of tan theta is sec square theta. So the integral of sec square theta will be tan theta. So here we go. First function and integral. So that is tan theta minus, inside a very big integral, we have to perform that derivative. The derivative of sec theta is sec theta tan theta, and I copy the same thing, tan theta d theta. I'll repeat once more. This and this will be the same, so I just copied the same thing, and that gives me sec theta tan theta minus integral sec theta and tan square theta. Tan square theta is actually sec square theta minus 1 d theta. So we open the bracket. So we get I is equal to sec theta tan theta. I'm going to skip a lot of steps, so please be aware that many steps are getting skipped over here. So look at this. This is I. And this is also I. Look at this. We started with sec cube theta d theta. That is I, isn't it? So this will be minus I. And when it goes to this side, we get 2I. And that is sec theta tan theta. And this will be minus of minus plus integral sec theta. And that is log sec theta plus tan theta. And when I divide this throughout by 2, I'll get 1 by 2 here and here, or I can take common. Okay, now I cannot afford more steps, so I'm going to substitute it here. Okay, so can you tell me what will happen here? So this will be 2a, and I just plug in this formula. So 1 by 2 comes common. Sec theta tan theta plus log sec theta plus tan theta within the limits theta equal to 0 to pi by 4. I hope you understood. We are integrating this part, and it's between 0 and pi by 4, and that's it. We are almost near the answer. Okay, now let's plug in the value. Cos pi by 4 is 1 by root 2. So the reciprocal is root 2. Tan pi by 4 is 1. So root 2 into 1 is root 2. Plus log, that will be root 2 plus 1 minus the lower limit. Cos 0 is 1. So sec 0 is also 1 by 1, that is 1. Tan 0 is 0. So basically this becomes 0. Plus log 1. Log 1 is 0. The answer is 8 times root 2 plus log root 2 plus 1. Okay, you can try some other method for integration. You can put that in the comment box. Let's move ahead with another problem. Okay, please write the next question. Find the length of the asteroid. Okay, I hope you remember the asteroid. So let's write like this. The standard equation of the asteroid is x to the power 2 by 3 plus y to the power 2 by 3 equal to a to the power 2 by 3. And then we make the standard asteroid. I hope you still remember the asteroid. It looks like this. It looks like this. Here and here. And fact, this is x equal to 0 and this is x equal to a. And I told you one more thing. While doing problems in asteroid, the parametric form will be very helpful. So I'm going to convert into parametric form. Anyway, you can see that if I can find this length from 0 to a, all I have to do is I have to multiply by 4. So please write total length. Please write total length is equal to 4 times length from 0 to a. And what's the formula? X equal to 0 to a integral root under 1 plus dy by dx the whole square dx. Once more I'll tell you, it is not compulsory that you have to convert into parametric form. You can differentiate directly, substitute, and then also you can simplify. Sometimes that method will be easier. Anyway, I'm going to convert it into a pure trigonometric problem and then try. So we need a lot of things. We need dx, we need dy by dx, and we need the limit in terms of theta because the parameter is theta. So that is exactly what I'm going to do now. X is equal to a cos theta the whole cube. And y is equal to a sin theta the whole cube. If you want, you can write like this so that applying chain rule will be a little bit easier. So what's the derivative of cos theta the whole cube? Yeah, 3 cos theta the whole square times minus sin theta. And what about dy by d theta? 8 times 3 sin theta the whole square times cos theta. So basically dy by dx will be second by first, or dy by d theta by dx by d theta, and that is going to be, of course, negative because there is a negative over there. So a cos theta the whole square times minus sin theta. So a 3 and everything will get cancelled, and that's negative. So we're going to get minus sin theta by cos theta. So what will be 1 plus dy by dx the whole square. It will be 1 plus sin square theta by cos square theta, and that will be cos square theta plus sin square theta by cos square theta, and that is 1 by cos square theta. So root under 1 plus dy by dx the whole square is 1 by cos theta. So that settles it. Now we need, look at this, I'm calculating 1 by 1. I calculated this. Now dx is also ready. Anyway, I'll write that dx here once more from here. That is a 3 cos theta the whole square minus sin theta d theta. So we got this. Now the major work, limit. We have to change the limit. So what is the x value? Because we have x values over here. So x equal to a cos theta the whole cube. So cos theta the whole cube is equal to x by a. So cos theta is equal to cube root of x by a, or the whole power 1 by 3. So theta is equal to cos inverse x by a the whole power 1 by 3. Now write, if x equal to 0, that is the lower limit. I am going to plug in the lower limit and upper limit, and I am going to get the value of theta. Cos inverse 0 by a, cos inverse 0 is 90 degree or pi by 2. Now let's plug in x equal to a. So theta is equal to cos inverse a by a, that is 1, and cos inverse 1 is 0. So we are ready with everything. I'll put tick here, and tick here. So let's substitute. So the required length is 4 times, and theta varies from pi by 2 to 0. I got it here, pi by 2 to 0, and this is 1 by cos theta, and here we have a into 3 into cos theta the whole square into minus sin theta d theta, and this cos theta gets cancelled. So 3 into 4, that will be 12a, and I'm going to flip the limits, and when I flip the limits, there will be a negative sign which will get cancelled with this negative, and we are left with sin theta cos theta d theta. Now you have two options. Either you convert this into beta gamma integral, or you can use the old technique, multiplying the numerator and denominator by 2. Anyway, I'm going to change this into beta gamma. 1 by 2 beta 1 plus 1, that is 2 by 2, 1, 1. That will be 6a gamma 1 by gamma 1 plus 1. So that will be 6a, this is 1, 1, 1, so that's it, 6a. So that's the total length of the asteroid. So that's it, my friends. I'll be back with more problems. In the next video, let's learn how to calculate the length in the polar coordinate system. So if you like the video, please subscribe, please share, and I'll be back soon. So till then, bye.